Hello everybody, today I can identify the properties of quadrilaterals by drawing the shape. More informally, I call this lesson Parallelogram Properties. It is a very important lesson because we're going to build on this in so many different ways. And in order to build on it, we need to know the different parallelogram properties. So that's what we're going to talk about. So first off, here are your different types of parallelograms. So you have your irregular standard parallelogram up top. It's kind of like, informally, it looks like a slanted rectangle, but we're going to learn more precisely what that means, now in this high school course. Rectangle, you see, is drawn beneath that. You have your square, you have your rhombus. So let's talk about the different properties of the parallelogram first, and then we'll talk about how they all relate to them. So, for a parallelogram, it is always the case that the opposite sides are congruent. Is that the case for a rectangle? Yes. In a rectangle, the opposite sides are congruent. Is that the case for a square? Yes. In the square, the opposite sides are congruent. Is that the case for the rhombus? Yes. In a rhombus, the opposite sides are congruent. So one of the properties of a parallelogram is that two pairs of opposite sides are congruent, and that's the case for all of them. Another property is that opposite sides are parallel. That's kind of why they call it a parallelogram, because opposite sides are parallel. Is that the case for a rectangle? Are the opposite sides parallel in a rectangle? Yes. Is that the case for a square? Are opposite sides parallel for a square? Yes, and the symbol for parallel, it's like a little arrow. It's kind of like the congruent symbol where we're marking each thing with it, but it's an arrow. Rhombus also has opposite sides parallel. So again, the property of the rectangle, the other three have as well. Another property of the parallelogram is that it has opposite angles congruent. Those are congruent, and then these ones are congruent. Is that the case in the rectangle? Yes. In a rectangle, they're all right angles, so they're all congruent. That's the case in the square, and that's also the case in the rhombus. And there's one more property that's important to talk about for the parallelogram, and that is that the diagonals bisect each other. The diagonals are cutting each other in half, and that is true for the other three as well. There's one other property which isn't as important, but I can talk about quickly. In a parallelogram, the consecutive angles are supplementary. So if I take a look at this angle and this angle, they're going to always add to 180, and that will be the case for the rest of them as well, but I don't really want to focus on that property too much. So, parallelogram has four main properties. You're going to definitely want to take a picture or a screenshot of this right here. Normally, I would, normally, I don't know what year you're going to see this in, but I'm going to be quizzing you on memorizing this. So everything on the left, those are the 5 different ways to prove a parallelogram. The last one is not going to really apply today because that incorporates the first 2, the opposite sides congruent, the opposite sides parallel. So don't worry about that one so much today, but these 4 properties are the properties of all parallelograms. They're also the properties of the rectangle, the rhombus, and the square. So what that means is that all rectangles are parallelograms. It means that all rhombuses are parallelograms, and it means that all squares are parallelograms. So if you get into an argument with someone, you say, no, that's a rectangle, no, it's a parallelogram, no, it's a rectangle, no, it's a parallelogram. You're both right. If it's a rectangle, it is a parallelogram because a rectangle has these 4 properties. If a shape has those 4 properties, it's a parallelogram. So a rectangle is a parallelogram, a rhombus is a parallelogram, a square is a parallelogram. Now, let's talk about what additional properties a rectangle has. There are 2 main additional properties that a rectangle has. First off, it's got right angles. When you think of a rectangle, going back to elementary school, you think right angles. That's one thing that a rectangle has that a parallelogram doesn't. So, if I want to prove that a parallelogram is a rectangle, if I show that there's a right angle, that makes it a rectangle. Not all parallelograms are rectangles, but all rectangles are parallelograms, because for it to be a rectangle, it's got to have a right angle. The other property, it's kind of hard to see in this picture, but the diagonals are congruent. This diagonal is congruent to this diagonal. Does a rhombus have these properties? Does a rhombus have right angles? No. So rhombuses are not rectangles. Does a square have these properties? Does a square have a right angle? Yes. Does a square have congruent diagonals? Yes. So a square is a special type of rectangle because for something to be a rectangle, it's got to have right angles. A square does. It's got to have congruent diagonals. A square does. So going back to this picture, squares are rectangles, squares are parallelograms. And if we look at this picture here, and I got a lot of diagrams going on here, these are the 2 ways to prove a parallelogram is a rectangle, the 2 additional properties of a rectangle, right angle, and congruent diagonals. But understand that a rectangle has these 2 properties plus these 4. Let's talk about the rhombus. The rhombus has 3 additional properties. The main property I think of when I think of a rhombus is that all sides are congruent, or consecutive sides are congruent. All the sides are congruent, but since a parallelogram already has opposite sides congruent, consecutive sides are congruent. Does a square have that? Yes, a square does have all or consecutive sides congruent. What's another property that a rhombus has that a parallelogram doesn't? Well, there are 2 that deal with the diagonals. This is a very important one. The diagonals are perpendicular to each other. The diagonals make right angles when they meet. Is that the case for the square? Yes. And the last property that the rhombus has, that the parallelogram doesn't, is that the diagonals bisect the angles. The diagonals are cutting the angles in half. Is that the case for the square? Yes. So, in order for something to be a rhombus, it has to be a parallelogram. It has to have those 4 properties. We showed it did earlier. And then it has to have consecutive sides congruent, which a square does, and it has to have a diagonal that bisects the angles, which a square does. That makes a square a rhombus as well. So, we come up with what we call the parallelogram diamond. All these shapes are parallelograms. All rectangles are parallelograms. All rhombuses are parallelograms. All squares are parallelograms. All squares are rectangles. All squares are rhombuses. So think of this as like a family. So like the parallelogram is like the old ancestor, and then down the line, I don't want any anything going on within the family here, but then the rectangle and the rhombus got together and they made baby square. So you got mama rhombus, you got papa rectangle, they had a square. That's their child. And remember, if you have a child, if you have a child, your child takes properties from both the mother and the father. So the square has all of mama rhombus's properties, The square have all of Daddy Rectangle's properties. The square also has all of the properties of the parallelogram, and so do the rectangle and the rhombus. Think of like parallelogram being like a human, and then rectangle and rhombus are a couple, and they made the square. So again, they're all parallelograms. All rectangles are parallelograms. All rhombuses are parallelograms. All squares are parallelograms. And then the rectangle and the rhombus, which are not related, except for the fact that they share the properties of the parallelogram, they got together, they made a baby, the square. So the square is a rhombus, the square is a rectangle, the square has all the properties of the rhombus, the square has all the properties of the rectangle, the square has all the properties of the parallelogram, the rectangle has all the properties of the parallelogram plus these two, the right angle and the congruent diagonals, and the rhombus has all the properties of the parallelogram plus these three. So we did a lot of talking. I know this lesson's a lot of talking, whether it's in person or if it's here. It is a lot of talking, but I think at this point we're going to kind of sum up what we talked about so far, and then we're going to be ready to move on. So these are your properties of your parallelograms, rectangles, and rhombuses. It is important for you to understand how they kind of mesh together with each other. All of these, all shapes, parallelogram, rectangle, rhombus, square, has these four properties. Rectangles have these two plus these four. Rhombuses have these three plus these four. Squares have all of them. Square has every single property that you see on here. Now, let's answer questions based on that first, and then we'll talk about how to prove each shape. Oh, trapezoid. Let's talk about trapezoid. So, an isosceles trapezoid, a trapezoid in general really just has one property. One pair of opposite sides are parallel. One pair of opposite sides are not parallel. That's what makes something a trapezoid. One pair of opposite sides are parallel, one pair are not parallel, so it's not a parallelogram because a parallelogram has two pairs of opposite sides parallel. So, what does an isosceles trapezoid have? It has congruent diagonals. It does not have diagonals that bisect each other. It's not a parallelogram, so diagonals don't bisect each other. You're going to see that comes up a lot. And it's got two pairs of congruent angles. They're neither consecutive. I mean, they're technically consecutive, but not all consecutive angles are congruent. Basically, the two top angles are congruent, the two bottom angles are congruent. That's it. So the ones at the bottom here are special for isosceles. And then a regular trapezoid, it doesn't have the diagonals bisect each other. The main property is that one pair of opposite sides parallel, one pair of opposite sides not parallel. All right, so which of the following is not true of all rectangles? So let's look at a rectangle. Now, right now, we have the rectangle here, but when you're taking a test, draw a picture of a rectangle. But understand that what properties does the rectangle has? It has these, and it has all the parallelograms, because a rectangle is a parallelogram. So when I draw my shape, I want to draw it really long, because if I don't draw it really long and skinny, then it might not be clear which properties it has and which properties it doesn't have. So, which of the following is not true of all rectangles? Consecutive sides perpendicular. Yes, the consecutive sides are perpendicular. Perpendicular lines form right angles, so yes, that one is true. Opposite sides are parallel. Are the opposite sides parallel? Yes, the opposite sides are parallel. I can tell from my drawing. That's true. Diagonals are perpendicular to each other. Are these right angles where the diagonals meet? No. And that's why we draw it really long and skinny. If we didn't draw it really long and skinny, we might not, that property might not have been as obvious. Diagonals bisect each other. That one's a little hard to see. And that's just one I kind of want you to know because it is a little bit harder to see. And for all of the shapes that we're talking about, not the trapezoid, but the whole parallelogram family, diagonals bisect each other. So, which one is not true? Choice 3. Diagonals are not perpendicular to each other. Diagonals are perpendicular to each other in the rhombus and in the square. Again, the square has all the properties that you see on the page. Number 2, which of the following is true about rhombuses? So we're going to draw the rhombus. If you haven't already, take a picture or a screenshot of this, or just, do it the old-fashioned way and write it down. If you haven't already, take a picture or a screenshot or write this down because we're going to be referring to it a lot throughout. All right. So we're going to be referring back to your screenshot for a little bit. I want you to try number 2 on your own. Which of the following is true? Go through each of the choices, mark your picture up, and see which one is true and which one is not. I'm just going to sit here for about 30 seconds while you do it. All right. Consecutive sides are perpendicular. So the consecutive sides, the sides that are touching, they're perpendicular if they form right angles. That is not a right angle. That is not true. Opposite sides are congruent. Are the opposite sides congruent? Yes, they are. Consecutive angles are congruent. Well, consecutive angles would be this one and this one. No, this one's acute. This one's obtuse. They're not congruent. Diagonals are congruent. No. When you have a slanted shape, the diagonals are not going to be congruent. This one is obviously longer because it's being pulled out that way and that way, and this one is being pinched in. If it's slanted, the diagonals are not going to be the same. The green one is obviously longer than the black one because it's being pulled in both directions. So, diagonals are not congruent. The answer is choice 2. And again, the best way to help you remember that, as far as the diagonals go, if the shape is slanted, then the diagonals are not going to be congruent. They bisect each other, they cut each other in half, but they are not congruent. I want you to try 3 and 4 and 5 on your own right now. So please pause, try 3, 4, and 5, and then unpause. Okay, now that you tried 3, 4, and 5 on your own, which of the following is false about all parallelograms? So I'm going to draw a long, skinny parallelogram. I draw the diagonals in because they often ask about properties of the diagonals. And again, worst comes to worst, you're going to refer to this and look at these properties here. Again, we don't worry about this. This one's a combination of the first two. But that's going to come up later in the unit. Diagonals bisect each other. True. Diagonals are perpendicular to each other. Are the diagonals forming right angles when they meet? No. Opposite angles are congruent. Yes. Acute, acute. Yes. Obtuse, obtuse. Consecutive angles are supplementary. We talked about that one briefly. And yes, if you have an acute and if you have an obtuse, they're going to be supplementary. They're going to add to 180. Because within this shape, you have your parallel lines cut by a transversal. And remember, in that picture, if you have one acute and one obtuse, they add to 180. So which one's false? Number 4, a quadrilateral whose diagonals bisect each other and are perpendicular. Well, let's start with the bisect each other. Diagonals bisect each other happens in the entire parallelogram family. So we can rule out trapezoid. Perpendicular. Again, you can refer back to this, or you can just draw the shapes. So a rhombus, a rectangle. Again, I'm going to draw it really long and skinny. That way I can more clearly see the properties. Diagonals perpendicular. Those look good. These are definitely not perpendicular. These are definitely not perpendicular. It's got to be a rhombus. And again, if you refer back to this right here, you have that property right there. That's your rhombus. I want to clear this ink off. Okay. Number 5, if the diagonals of a quadrilateral do not bisect each other, it's got to be a trapezoid. The entire parallelogram family has a trapezoid. I'm sorry, the entire parallelogram family, that makes no sense, has diagonals that bisect each other. So if the diagonals don't bisect each other, it's not in the parallelogram family. Trapezoid's kind of the outcast. Trapezoid is not in the parallelogram family. It does not have the properties of the other parallelograms. All right, let's skip ahead to number 10. Let's go back to this picture. To prove these shapes, to prove the parallelogram, I have to do one of these 5 things, but again, the last one's not going to really come up today. So, in order for something to be a parallelogram, it needs to have one of these 4. Period. In order to be a rectangle, it needs to first be a parallelogram. So it needs to first have one of these 4, or say that it's a parallelogram, and have one of these 2. That's how I would prove something is a rectangle. A rectangle is a parallelogram with one of these 2. A rhombus, to prove a rhombus. Well, a rhombus must first be a parallelogram by either proving one of these 4 or it telling you that it's a parallelogram. Once it's a parallelogram, you then have to know one of these 3 things. So a rhombus is a parallelogram with one of these 3. A square has to be a parallelogram. It has to have a property of Papa rectangle, and it has to have a property of Mama rhombus. Again, it's the baby of the rectangle and the rhombus, so it has to be a rectangle, has to have one of the rectangle properties, has to be a rhombus, has to have one of the rhombus properties. So, to kind of sum this up, a parallelogram, I'm not going to write that, you have to prove one of those 4. A rectangle is a parallelogram with one of its 2 properties, a right angle or congruent. diagonal. A rhombus is a parallelogram with one of those three: consecutive sides congruent, diagonals perpendicular to each other, and diagonals bisect the angles. And then the square, a square is a parallelogram with a rectangle property and a square and a rhombus property. It's a little bit smaller. So, again, this relates to this. A parallelogram, you have to prove one of these four. Once it's a parallelogram, to prove it's a rectangle, you have to prove it's a parallelogram first, then prove that it has one of those two. To prove it's a rhombus, you have to prove it's a parallelogram first, then prove it has one of those three. To prove it's a square, you have to prove that it is a parallelogram first. It's got a property of Papa rectangle. It's got a property of Mama rhombus. Again, a lot of talking in this lesson. It is what it is. So, number 10 says a parallelogram must be a rhombus when? Well, to prove that something's a rhombus, it must be a parallelogram, check, and it must have one of these three properties. So the answer is going to either be diagonals are perpendicular to each other, diagonals bisect the angles, or consecutive sides congruent, or something that means the equivalent of one of those three. So, diagonals are congruent is not a property of the rhombus. Opposite sides are parallel. Now, that's true, but that does not prove it's a rhombus. Again, I'm looking only for one of these three. I keep on losing the page. Diagonals are perpendicular. Yes. That's that property right there. The answer has to be one of these three. So that's it. Opposite angles are congruent. Again, that is a property of the rhombus, but it does not prove it's a rhombus. To prove it's a rhombus, it needs to first be a parallelogram and then have one of these three properties. So your answer is choice 3. A parallelogram must be a rectangle. So to prove something's a rectangle, I first have to prove it's a parallelogram. Done. Now I have to prove it has one of the rectangle properties. It's got to either be a right angle or congruent diagonals or some version of that. So, diagonals are perpendicular. No, that is a property of the rhombus, not a property of the rectangle. And again, it might help if you draw the shape. But I really want you to for these types of questions, just to refer to this page, which you have, again, either written out or screenshotted or a picture of. Diagonals are congruent. Yes. It's got to be one of those two. That's it. Let's go through the rest. The opposite sides are parallel. I mean, that's true. It's a property of the rectangle, but it does not prove it's a rectangle. Opposite sides are congruent. It's a property of the rectangle, but it doesn't prove it's a rectangle. So let's talk about the difference of that. Let's talk about the difference between being a property and proving. Two pairs of opposite sides congruent is a property of the rectangle. Two pairs of opposite sides congruent does not prove it's a rectangle. It proves a parallelogram, but does not prove a rectangle. Two pairs of opposite sides parallel is a property of the rectangle. It does not prove it's a rectangle. A right angle is a property of a rectangle. A right angle proves that a parallelogram is a rectangle. So these are all properties of the rectangle, but only these two prove that a parallelogram is a rectangle. Same thing with the square. Same thing with the rhombus. Excuse me. For the rhombus, these five are a property of the rhombus. These five do not prove it's a rhombus. To prove it's a rhombus, to prove a parallelogram is a rhombus, I have to prove one of these three. All 8 are properties of the rhombus. Only these 3 prove that it's a rhombus. And for a square, again, to prove it's a square, it has to be a parallelogram, it has to be a rectangle, it has to be a rhombus. It needs to be all 3. The rectangle must be a square when? Well, a square is a baby of the rectangle and the rhombus. Since it's already a rectangle, it just needs a property of mama rhombus. So it's going to need one of these 3. That being said, I want you to try and answer this question on your own from there. Prove something's a square is a baby of the rectangle and the rhombus, so it must have a property of the rectangle and a property of the rhombus. It's already a rectangle, so we just have to prove it's a rhombus. Take about 15 seconds and try it on your own. Which is a property, which is a way to prove a rhombus? Choice 3. Consecutive sides are perpendicular, makes it a rectangle. That's a right angle at the angle. Diagonals are congruent is a property of the rectangle. Again, it's already a rectangle. I need to have the property of the rhombus. Diagonals perpendicular to each other. There's your rhombus property. Opposite sides are parallel. That's a property of a square, but it does not prove it's a square. Again, in order to prove a rectangle is a square, if it's already a rectangle, it's got to have one of the 3 for mama rhombus. That was a perpendicular. I want you to try 13 and 14 on your own. So please pause, try 13 and 14 on your own, and then unpause. Okay, a rhombus must be a square. Well, to prove a square is the baby of mama rhombus and papa rectangle. If it's already a rhombus, it needs the papa rectangle property. So it needs one of these 2. Period. The answer is going to either be congruent diagonals or somehow creating a right angle. It could say a right angle, it could say consecutive sides perpendicular, but it's got to be one of those 2. So, which of the choices is one of those 2? Consecutive sides are congruent. Okay. Opposite angles are congruent is a property of the square. Diagonals are perpendicular is a property of the square. Consecutive diagonals congruent is a property of the square. But in order to prove that something's a square, it must be a rhombus, it must be a rectangle. It's already a rhombus. Oh my god, this is wrong. Hold on. Sorry, got distracted. A rhombus must be a square when? So again, it needs to have a property of the rectangle. It has to have a property of the rhombus. Since it's already a rhombus, it needs to have a property of the rectangle. So it's got to have one of these 2, a right angle or congruent diagonals. I kind of read it too fast when I looked at the choices, so make sure you read it nice and slow. Diagonals congruent would be the answer. If it was consecutive sides are perpendicular, that would be an answer. I read it a little bit fast. And I asked you to do number 14. A parallelogram must be a rectangle. Well, again, for a parallelogram to be a rectangle, it has to be one of these two, either a right angle or congruent diagonals. So, do I see congruent diagonals? No. Do I see a right angle? Well, consecutive sides perpendicular makes a right angle. That would be your answer. So again, to prove a parallelogram, it's got to be one of these four or these five. To prove it's a rectangle, it needs to first be a parallelogram by proving one of these four or just telling you that it's a parallelogram, and then one of these two. To prove it's a rhombus, it needs to be a parallelogram, and then one of these three. A square is the baby of the rectangle and the rhombus, so it has to have one of these two or be a rectangle, and it has to be one of these three or be a rhombus. All right, I know this lesson's a little bit long. There's one more type of question here, and now we're going to deal with actual shapes. If ABCD is a parallelogram, which statement would prove that ABCD is a rhombus? So we're going to draw rhombus ABCD. We're going to draw in the diagonals. It wants me to prove that a parallelogram is a rhombus. So in order to prove that a parallelogram is a rhombus, it's pretty straightforward. I need one of these three. I need diagonals perpendicular, diagonals bisect the angles, or consecutive sides congruent. ABC, CDA. These are opposite angles congruent. That is not one of the three ways to prove a rhombus. It's a property of the rhombus, not one of the three ways to prove a rhombus. AC is congruent to BD. The diagonals being congruent does not prove a rhombus. And it's not a property of the rhombus either. It's a property of the rectangle, not a property of the rhombus. AC is perpendicular to BD. AC is perpendicular to BD. Diagonals are perpendicular to each other. Yes. That is one of the ways to prove a rhombus. And you're going to see that property come up a lot. And finally, choice 4. I like to always go through all 4 choices. AB is perpendicular to CD. That is not true. They're parallel. And even if that were the option, that does not prove it's a rhombus. That's a property of the rhombus. Your answer is choice 3. So now these last few questions are kind of taking all those properties and applying them to an actual shape. 20, in parallelogram ABCD, diagonals AC and BD intersect at E. Which statement does not prove that parallelogram ABCD is a rhombus? So again, I'm going to draw rhombus ABCD. I'm going to draw in the diagonals. And it wants to prove which statement does not prove it's a rhombus. Well, to prove it's a rhombus, it needs to be one of these three. So because it says which one does not prove it, it's going to be whichever one is not one of those three. So diagonals perpendicular proves it. Diagonals bisect the angles proves it. Consecutive sides congruent proves it. AC is congruent to DB. AC, DB. Those are diagonals. Are the diagonals congruent? Is that a way to prove a rhombus? No. AB is congruent to BC. Consecutive sides are congruent. Yes, that proves a rhombus. AC is perpendicular to DB. AC, DB, those are diagonals, perpendicular. Yes, diagonals perpendicular proves a rhombus. AC bisects angle DCB. DCB is bisected. Yes, diagonals bisect the angles is a way to prove a rhombus. Those are the 3 pictures that I have here. So which one does not prove it's a rhombus? Choice 1. Choice 1 would prove it's a rectangle because diagonals congruent proves a rectangle. Why don't you try number 21 on your own right now? And then, so please pause, Try number 21 on your own, and then unpause. Okay. In the diagram below, parallelogram ABCD has diagonals, blah, 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 which expression is not always true. So it's not saying anything about a rectangle or a rhombus or a square. It's just talking about a parallelogram. So we are just, again, I keep on circling this stuff, and it gets kind of wild by the end. So we're just looking at these properties. DAE, BCE. Well, this one's got a little twist to it. This actually is not one of those, but these are altered interior angles, which come from opposite sides being parallel. So yes, this is true. That's kind of an extension of opposite sides are parallel. DEC, BEA. This also is not one of those five, but that's vertical angles. So that's true. AC congruent to DB. AC and DB are the diagonals. Are the diagonals congruent in a parallelogram? Are they congruent in a slanted shape? No. DE is congruent to EB? Yes. Diagonals bisect each other is a property. So choice 3 is right. So I know we skipped around a lot. Your classwork / homework is to now go back through all the different ones that we skipped. Listen, I know this was a very long, very conceptual lesson. What you need to know, this. All right, you need to know all your properties of the parallelogram, rectangle, rhombus, and square, and how they relate to each other. All of these, as far as properties go, a parallelogram has all these properties. A rectangle has these properties plus these properties. A rhombus has these properties plus these properties. A square has all of these properties. As far as proving the shapes, understand the parallelogram diamond. All rectangles are parallelograms. All rhombuses are parallelograms. All squares are parallelograms. All squares are rectangles. All squares are rhombuses. Rectangle and the rhombus got together. They made the square. So to prove something's a square, it has to have a property of the rhombus. It has to have a property of the rectangle. It has to be both. To prove a rectangle, it has to be a parallelogram first. So that brings us to this. To prove a rectangle, I have to first prove it's a parallelogram and then prove one of these two. To prove it's a rhombus, I have to first prove it's a parallelogram, then I prove one of these three. And to prove it's a square, it has to first be a parallelogram, and then it's the baby of the rectangle and the rhombus, so it has to have one of these and one of these. Again, your classwork / homework is to finish parallelogram properties or quadrilateral properties. And we're going to be building on this for the next month. So it's really, really, really important that we get comfortable with these properties. Have a great day.